Okay. Don't I am pressuring or overwhelming, but that's what I am. If you are good in the subject, then you have to finish. Hey guys, I'll join in a minute. Hi guys. How are you all? Sorry guys, I was 3-4 minutes late. How are you all? Chutwa. Because what time is it? 6:50. Hi guys, how are you all? Dhruv, Sanvi, Arush.
I'm good.
See, next week we'll have a 2025 question test, guys, 100%. Okay. If I don't keep it, I feel very bad. Okay, I did not know. Where are you? All that stuff comes into my mind. Makes sense? Can we have a 2025 question test? It will not take much of your time. Is that okay? Does it sound like a plan? Okay. Did we start transformations last week? Where is Sanvi, Arush, Anirudh? Did we start transformations last week? No, right? With you guys? Okay. Transformation is something I want to start with.
Bro.
I have some messages. What do you want to convey to me? Yes, please, Sanvi, go and come back. Sure. Avyuk, did you get your sharpener?
Yeah,
Good, good. Can we move on? 1 minute, guys.
Aniket, can you get me the other cooker?
You want to mute?
The other one.
Talking to his brother.
The Fender one. The
Oh,
one
I'm
that
not
says
able to.
Fender.
I'm not able to mute him. Okay. Shall we go ahead? Okay.
Yeah, I had a question on the homework.
Oh, absolutely, Ma. See, I forgot to ask, and I'm glad you're asking. Okay. Who had a question, Ma? Who had a question?
Danvi.
Oh, Danvi had a question. Okay.
It's not that I couldn't solve it, but it's more like the fact of how I did it though. Give me a sec. Let me go to the question. It's question 50.
Wait a minute. Can I share my screen?
Okay.
Mm-hmm. Pythagorean theorem, right? Right, Danvi?
Yes.
Mm-hmm. Pythagorean theorem. I have to share my screen, right? I'm slow today, guys. Too many things going on. Okay. Tell me. What is your question? What is the question number?
Question 50.
Number 30, yeah. 30?
50. 50.
Mm-hmm.
So my question is that I was solving it and like I was asking my dad to like check all my answers, and he solved it in a completely different way. So for this, I didn't exactly use like Pythagorean theorem, but
you did.
I did, but I also didn't.
Mm-hmm. Okay, let's see.
So
Go ahead, Go ahead, Danvi.
how I solved it was that because like the height opening in his entertainment center is 27 inches, so usually the opening is 4 to 3. So I did like what do you call it? If 3 is in this thing, 3 is essentially the 27. So what I did is that 3 times what equals 27, which is 9. So I multiplied 4 by times 9 too, and
That's all. You solved it using proportions. You didn't use Pythagorean theorem, I understand. Okay. Okay. How did your dad solve?
and he uses like the Pythagorean theorem. I don't remember exactly how he used it, but all I know is he used like the actual Pythagorean theorem.
You cannot use Pythagorean theorem, right? I don't see how, meaning, see, I do understand this comes under Pythagorean theorem. I don't deny it, okay? But at the same time, without using proportions, this cannot be solved, right? Right, Danvi?
Yes.
So I am with you. The way you solved it is perfectly right.
Okay, thank you.
Make sense?
Okay, yeah.
Okay. Any other questions?
Miss Priya,
Yeah.
on the homework, there weren't any answers for number 48 through 51.
Okay. You want to check something?
Yeah.
Sure. 48 through 51. Okay. For this one, answer is what? This is
For 50?
yeah. This one is 4 9 4s are 36 is the answer.
For 50?
Wait.
I thought it was
Oh
45.
yeah. I'm sorry. After the Danvi, the question is diagonal measurement, right? So you have to use Pythagorean theorem after proportions. You also used it, right?
I did for this one, yes.
No, that's the same question, right?
Wait a minute. Give me a second. Actually, wait, now that I think about it, give me a second.
So you have to use.
That's how my dad solved it. How I did it was width to height ratio is 4 to 3. So I squared both of them. So it's 9 and 16. 16 times 6, but I added both of them, which is 25. I did the square root of that, which is 5, and then I multiplied 5 by 9.
5 by?
5 times 9.
Why 5 times 9? That is incorrect. Why 5 times 9?
So the thing is, instead of using Pythagorean theorem, what I did is that
I see. I got it. So you used proportion still, is it?
yeah, but I didn't.
Yeah,
use,
but you use the 3:4:5 Pythagorean triplet, right? So
yes.
it's perfectly correct.
But the third thing is like the way that my dad and I solved it like was completely different. So my dad has wanted me to check like which one would be correct.
Oh, yeah. See, okay, one thing is using proportions, like you said, right? 3/4 equal to 27 by what? That gives you one of the
27
legs.
by.
Okay, after that, you have to do 27 square plus 36 square equal to the diagonal square. Did you do that?
Yeah, that's what I did too.
But this is, yeah. So the other way of doing it is 3:4, right? You can use Pythagorean theorem on that 3 and 4. The other side is 5, you know. Now, actual measurements are multiplied by 9, multiplied by 9. This can also be multiplied by 9. Perfectly right.
Exactly what I did. And
Yeah,
my
that
dad,
is fine. Both are correct.
yes. So
Miss Priya, so for number 50, I got 45. So is that right?
That's right.
Okay.
Hey, Ashrita, you're here, right? I was communicating with your mom.
Oh. Oh,
On
yeah.
map. Yeah, map test is very good.
Thank you.
Okay, good job.
Thank you.
Now, 51, somebody wanted two people leave from the same point. One travels 12-meter north, the other travels 9-meter east. 9-meter east means this side. So how far are they? It's a Pythagorean triplet, right? 144 plus 81. What is it?
I got
225. So they are 15 meters apart.
Oh.
Make sense? Riyanka, did you do the homework?
I did it. I didn't do I did it. I just didn't finish it because every single day I do a specific amount of questions, and it said that it was due today, so I didn't do the amount of questions I was supposed to do today yet.
Yeah. But did you try the entire homework?
I didn't. I did it until about 50, and I just need to do the last 10 questions. I just didn't do that yet today. I'll submit it once I finish the 10 questions.
Okay. Okay, let's move on. What other questions you want answers? What other questions you all had? You want me to work out any other question, guys? Quickly tell me, guys. I want to move on to transformations.
Miss Priya,
Yeah.
this isn't about the homework, but is this the last class?
We have one more class, right?
Uh, um,
Tell me.
I don't think I'll be able to attend it.
Are you going to India?
Yeah, next Tuesday.
Okay. See, next Tuesday, okay. See, one thing is I want you to attend the test whatsoever, okay, Anirudh, then only we'll know where we are, right?
Yeah.
So why don't, meaning, ask your dad or mom to ping me for the test. I'll send the test to you. Why don't you try it out?
Okay.
Priya.
Okay, then I'll send the scores as well. So we will get to know where we are, right? Before moving into the next new year. And it is justifiable to write the test. Okay, take it as a test. Don't abuse it. Okay, just because you're taking it offline. Got it?
Okay.
Okay. Will you inform your dad or mom to ping me for the test? I don't have the test. Okay, I have to work on every class test now only. Okay, I'm just jammed with work. But then on the day of your class, you or after going to India, just ask your parents to ping me. I'll send. Okay.
Okay.
Make sense?
Yeah.
Okay, good.
I'm also in India, so I'm missing next class. Should I just message you as well?
Yeah, absolutely, ma, please. Okay. Meaning, then only you will know where you are, right? You will be happy writing it. That's why I'm saying.
Okay, thank you.
Yeah, and some of you, meaning, see, for some of you, it's going to make you happy. That's fine. If we are going to struggle, we need to identify where we are struggling as well, right? It's not always like we'll all get a 90, 80. No, right? So it's okay. Whatever it is, we have to know. Okay, now what did I want to do? Transformations. Can we move on? Any other questions here? Okay, good. In the other class, I already did 2 classes of transformation. It's interesting. I don't know how. Okay, let's see. G7. It's just that. Hey, did I tell you how to do MAD? I did, right? Okay, good. We did that. Very nice. Okay. Okay, dilation.
I like spend like the last 5 minutes of class on like MAD. So
Which one, ma?
on MAD,
What is it?
we kind of just like spent like the last 5 minutes of last class just going over MAD.
For which one? Which one?
Mean absolute deviation.
That is enough. There is nothing more other than that on that, right?
Mm-hmm.
So absolutely fine, right?
Okay.
Okay, let's go ahead. Oh, wow. Okay, let's move on. I'll stop share. I want to share my notes page. We are very slow today, I know. Let's see. Hey, Prince, what are they doing in school, Prince? And Prisha, what are they doing in school? I'm curious. And Riyanka, what are you doing in school?
We just finished sorry. Can I, we just finished like dilation, rotation, and like translations and stuff like that. And I just took like the test for that today. But then that's pretty much it because we're probably not going to learn anything else this year because school ends next week on Wednesday.
I see. Okay. Let's see. Okay, I'm going to post all the questions to you then. Let's see today. Prisha, how about you?
We just finished mean absolute deviation last week, and this week we haven't been doing anything that
Oh,
much.
so they didn't cover transformations?
Yeah, I think we did it one or 2 days, and then I think we were supposed to do it this week, but they didn't do
Okay.
it.
How about you, Ashita? Did you do transformations at school?
We didn't start transformations yet.
Okay, that's fine. No problem. Okay. Anybody else in this class? Avyukt, I did not get any comment from you, Avyukt.
All right, so we had just finished our map tests and started our semester exam.
How did you do map? Can you message me?
Map?
Mm.
Oh, we started on map like 2 weeks ago.
Yeah, can you send? Did you finish it?
Yeah, I finished it.
Would you mind letting me know your score?
Yeah, sure.
Okay, just message me. Okay, guys. Now,
Wait, sorry. Do you want the entire class to message your score? Because I also
be
did.
nice, right? I would like to know how you guys do. Absolutely.
Okay, I'll send you it.
Same.
Yeah. See, so many things happen based on that. Okay, it's not like, hey, I note down and have judge you. It's not that. Okay, more than that, I will try to group in such a way. Similar scored kids are belonging to the same group. You see what I mean?
Miss Priya.
So those are the things it helps me when you update me. Yeah, tell me.
When I was doing my map test,
Uh,
it was genuinely confusing because like I was literally getting like college level like questions, like not just algebra too, but like calculus.
okay, can you message me your score, Danvi?
Okay. I'm not sure. My teacher didn't give out the our most recent scores,
Oh, okay.
but I'll give you like my older score. Like,
Oh.
what do you want? Just like the percentile.
Okay, yeah. No, I would want the number.
Oh, okay. Then I'm not sure because she doesn't give that out. She only gives a
But
percent.
you can always see it at the end of the test.
For us, we don't. We can't.
Okay, let's move on. So coming to transformations, right? Transformation means moving an object or moving a line, either sliding it, flipping it, or rotating it. Okay, good to know, Prince. Thank you. So now let's say I have a point, okay, or I have a line. Okay, this is A, B. 1 second, guys. This is 1 second, guys. You're going to hold off for a minute. you have flip, slide, turn. Okay. We are mathy people. Okay. We are no longer going to talk about flipping, sliding, and turning. Okay. We will be more sophisticated. We'll use mathematical terms. Okay. The line AB, if I slide it, right, I slide it to quadrant 1. What is it called? What can be a very sophisticated way of telling? Those who have studied transformation should tell me.
Translation.
Translation. Okay, translation. You see? So now here the x coordinate of the line is, let's say 1. Y coordinate of the line is, let's say 4. Oh, 1 second. Okay, 4. Now, if you move it in here, right? Let's say this came to same. Let's say it came to 2. 2 comma, this one is what? A point I did not mark, right? 1. So this is 2 comma 1. Okay. So this one would be 2 comma 1, but this would be minus 2 comma 1. Okay. This would be, so let's say from minus 2 comma 1, the point A dash, meaning after movement, right? After moving means after sliding the line to quadrant 1, it became 2. So how many units on the x-axis it moved? From minus 2 to 2. So I call that translation as x plus 4. So basically AB moved to A dash B dash. The x coordinate, when you look at it, right, it moved from minus 2 to 2, correct? And the y coordinate, what happens to the y coordinate? Y coordinate didn't change at all, right? So x moved 4 units to the right, comma y. This is the translation rule. Any questions? Sliding is just translation. Makes sense? Suppose, let's say I have a point. I'll do the points properly. You're going to answer, okay? So let's say this is A. Okay, now I want you to know this line before the transformation is called pre-image. The line after the transformation is called image. Any transformation, flip, slide, turn, any transformation is called pre-image. After it is called post-image. Okay. Now let's say I have a point minus 2 comma 1. Okay. I am sliding the point. I'm sliding the point 4 units right, 1 unit up. Okay. I give you the rule of transformation is x plus 4, y plus 1. What is the point A dash? Did you correct it? You're going to tell me, please. I'm going to wait.
You were kind of like breaking out, so can you please repeat the question again?
I'm asking you for the image A dash. A is the pre-image. What is the image? The translation rule is given to you. X plus 4, y plus 1. X coordinate moves to the right 4 units, y coordinate moves up 4 units.
Okay.
Go. You get it, guys? Are you each of you have different answers, guys? Why? Then I did not explain it properly. That's what it is. If everybody has a different answer, then I did not explain it properly. Ashrita, correct, ma. Ashita, have they covered transformations in school?
No.
Oh, okay, interesting. Riyanka, is that correct? How did you get 1?
Negative -3 plus 4 equals 1, and then
-3 or -2, right?
this is -3.
Which one is -3?
Oh,
Now show
I think it just looks like a -3 because the comma is right next to the 2.
Okay, I take your words, guys. So this was a -2, comma 1.
Oh, let me fix mine then.
Yeah, sure. Sanvi, good job. So what does the translation rule says? X plus 4. So you need to add 4, which makes it a 2, and then y plus 1. So a dash point is 2, comma 2. Any questions? Any questions? No
I have a
questions?
question.
Yes, please.
So I got 2,4.
2, comma 4. Why did you get 2, comma 4? Y is y plus 1, right, Avyu? I'm
Wait,
glad you're raising it.
I got the y-axis as 3 though.
Why did you get it as 3? Because it was -2, comma 1, right?
Oh, you're looking there. Oh, my bad. I was
No, no,
looking.
no. No, no. What was the problem? Oh, you were looking at this?
I was looking at this part.
Which part, Amma? Oh, you know what? Okay, yeah. Yeah, yeah. Wait. So this is 2 -2, comma. Wait, Vyut. -2, comma 3 da. So it should be 2, comma 4. Okay. Avyut, your answer is correct.
Okay.
Your answer is correct. Good job, Avyut. Nice raising it. Okay. So now translation, you all got what it is. Okay. But I did not say what is flipping, what is turning. Flip, when you flip it, right, you reflect it. Okay. The reflection has to be on a line. Okay. It can be on the x-axis. It can be on the y-axis. Reflecting on, see this one. It's going to be very interesting for you. This 1, 2, 1, 2, 1, 2, 1, 2. Suppose there is a point here. What is this point? 1, comma 2. If you reflect it on the x-axis, what happens? See the pattern. It's going to be interesting. When you reflect it on the when you reflect it on the, okay, let's say when you reflect it on the y-axis first, what is going to be the point?
It's gonna be -1. No, I mean, it's gonna be 2.
Do we shut it up?
Go ahead.
-1.
Negative 1, 2. Okay, I want you to see the pattern. There's going to be a pattern now. Negative 1, comma 2. Okay, fine. That's right, -1, comma 2. Let me put it. Now, the same point, I'm going to reflect it on the x-axis. What happens? Think about and tell me the point. What happens to the point when it reflects on the x-axis? Tell me, guys, it's not hard. When it reflects on the x-axis, what point will it be? Yeah, so Ashita, no. It's still 1, right?
Oh,
Oh,
Still 1, comma -2.
1 -2.
Yeah, exactly. Now, did you see what big change? When you reflect it on the y-axis, what gets negated? When you reflect it on the y-axis, x gets negated. When you reflect it on the x-axis, y gets negated. Did you see? When you reflect it on the y-axis, the y-coordinate remains the same. Okay, but the x-coordinate negates. When you reflect it on the x-axis, x remains the same, y gets negated. Make sense, guys?
Miss Priya,
Yeah.
why is it called a flip?
Okay, guys, why is it called a flip? Flip, what is the meaning of flip, Emma? What is the meaning of flip? When you flip a page, what happens? When you flip a page, what happens?
You move on to the next page.
You'll great, you'll move on to the next page. Let's say your y-axis is your spine of the book. When you flip a page, right, considering the spine as the y-axis, right, can it be called reflection?
I didn't get that.
Good. Dhruv says it's called flip because it gets reverted. See, okay, consider the y-axis as the spine of the book of youth. Consider y-axis as the spine of the book.
Okay.
Sense? Now, turn a page. You turn a page. Turn or flip a page. What would happen? Whatever happens there is like reflecting that point into, if you are in the first quadrant, the point moves to the second quadrant, right?
Mm-hmm.
At the same distance, like flipping a page, right? That's why flip is called reflection. Am I?
Yeah. You're muted.
Yeah, I don't know why I'm muted. Okay. So did you get that?
Yeah, I got it.
Okay. Now, let's go ahead. I know video is stopped. Now, let me go ahead and do something. Okay, can one of you share screen for me till I get in? Can one of you share screen? So now, do you all get what is translation and reflection? Meaning, if I reflect it on the x-axis, what coordinate negates, Dhruv? If I reflect something on the x-axis, what coordinate negates?
The y coordinate.
Auntie,
The y.
do you want me to share a whiteboard?
Yeah, Ma, thank you. For a minute only, for a minute or two. Okay. So again, to review, right? When you reflect something on the y-axis, what coordinate negates, Prince?
The X. I mean,
Yeah,
yeah.
x-axis negates. The meaning whichever axis you are reflecting, right? That coordinate remains the same. Think of a point. Okay, think of a point. When that point gets reflected, what happens? Think about it. Then you'll never make mistakes. Okay. When if you reflect it on the x-axis, x coordinate remains the same. Only y coordinate negates. Similarly, when you reflect it on the y-axis, y coordinate remains the same, but x negates. Okay. Now, we discussed translation. We discussed reflection. So, what I'm going to do is I'll share with you a cheat sheet. Cheat sheet in the sense, see, if I reflect x comma y on the x-axis, what happens? The point becomes x comma minus y. When I reflect it on the y-axis, the same point x comma y, the new image point, whatever was before the transformation was pre-image. The new image point becomes, suppose if you reflect x comma y on the x-axis, then the image point is x comma minus y. Any questions on this, guys? Do you have any questions on this? Guys, you need to tell me, guys. Do you have any questions till now? Do you have any questions? Hello?
No.
No.
Okay, so I thought I was not audible. Okay, so I'm going to move on to rotation. So that's why I keep on asking you whether you understand or not. Okay. Now my video is back. Okay, having said that, right, I'm going to give you one or two problems on whatever we have discussed first, and then I'll move on. Is that okay? So here. So translation, rotation. Okay. Now let's say I have a figure. Let me draw the figure for you and show you. Let's say, Riyanka, I managed Ma. Okay, that's why I didn't ask you to share. Okay. I lost internet. Okay, I managed. So now let's say I have a figure. What I want you to think about is I'm going to draw a figure. I'm going to talk to you about two different things. Okay. One is show you. One is orientation of the figure, orientation of the vertices, orientation of the figure. Think about this. If I want to know orientation of the figure, right? What is this orientation of the figure? I have a cross. Okay. I put a star on top. Now let's say if I translate it to the right, translate 5 units right. Orientation of the figure means this is my pre-image, right? The image will have the star on the top or not? Will it be like this? Will it be like this? You have to answer, oh, this become, see, will it be like this? Will the star remain on the top itself? As a result of translation, will the star remain on top or not? Tell me.
Yes.
Yes, when I slide it, the image, the pre-image is exactly as the image. It doesn't change shape. It doesn't change anything. Okay. So on translation, again, I get the same, but in a different place and the star is on top. So here I would say the orientation of the figure is preserved. Make sense? Now let me go to reflection. I don't think you would have discussed all this at school. So this is the important piece for you to understand. Okay, reflection. Suppose there is a figure here. There is a figure here. Now I'm going to reflect it. I'm going to reflect it on the y-axis. What do you think will happen? What do you think will happen if I reflect it?
The star
The
will get
star will still stay at the top.
It'll stay at the top, right, guys? Do you all understand that?
yeah.
When I flip that star, right, again I'll get the same image. So the orientation of the figure is preserved. Make sense?
So if you do it on the x-axis, would it be on the bottom?
Wait. Then, wait. We are for reflection. Let's think about it. Hold on. I need to check. On the y-axis, so it's going to go there. On the x-axis, see, okay. Let's consider the y-axis. Okay, here it is preserved. Okay, but if you reflect it on the x-axis, what happens? What happens?
Would it be on the bottom?
Exactly, it will become the bottom, so it's not preserved. So overall, there are scenarios in case of reflection, is the orientation of the figure preserved or not is what we are trying to understand. Okay, so before I go there, right? So in translation, is the orientation of figure preserved? In translation, is the orientation of figure preserved?
Yes. Yes.
Yes, orientation of figure, you're just sliding it, right? So when you think about it, the orientation of the figure is very much preserved in translation, right? So in reflection, what do you think about it? See, orientation of the figure means draw a star on top, okay? In your pre-image and image, will the star come on top in all the scenarios of reflection? That's something you need to think. That is called the orientation of the figure. Okay. Now, can you try thinking and letting me know in chat? So similarly, think about rotation. I want in 3 cases. Okay. These 3 cases are important pieces of transformation. Transformation means it can be rotation, reflection, translation. Okay. There is one another transformation which I have not talked to you about. I'm going to talk to you about. Okay. So go ahead and tell me the orientation of the figure is preserved in which of the 3 transformation? Orientation of the figure is preserved in which of the 3 transformation? It is not preserved in which of the transformation? That's what I want from you. Think about and slowly tell me. All the 3 you tell me. Translation, it's preserved. We already discussed that. Reflection and rotation, I want you to think and tell me. Not a hard one though.
Miss Priya,
Mm-hmm.
it's not letting me send.
Please double click, Amma.
It says you are not in
That
this.
is fine of you. Please double click the name. It will work.
Oh, okay.
Go ahead. I don't know. Zoom does it of you. It's okay. Go ahead. Yeah, translation is preserved. We know that. I just want from you reflection and rotation preserves the orientation of the figure or not. This is how you understand and perform transformation. Okay, don't memorize the cheat sheet. The cheat sheet memorization is very easy. Anybody can do. Preserved in... See. Reflection, it's not preserved, Ashrita. Because there so many cases, reflection, it's not preserved. Okay, if you find one case as well where it is not preserved, you have to say it's not preserved. You got it?
Oh, I put it's only preserved in reflection of y-axis.
Yeah,
And
yeah, don't do that, I'm saying. In general, in reflection, it's not preserved.
okay.
Okay, you cannot maintain that on the top itself in several cases. See, okay, I did not talk to you about this. That's why you're getting confused. I'll show you. See, you need not reflect it on the x-axis and y-axis. This line is called y equal to x. You can reflect it on this line. This line is called y equal to minus x. You can reflect it on this line. When you reflect on all these lines, the orientation of the figure is never preserved. You got it?
Yeah.
Yeah. Hey, Sanvi, no ma. Sanvi, it is preserved in translations, correct? If you rotate it, how is it preserved, Sanvi? If you rotate it, is it preserved? See, rotate means what? You're rotating this figure. Literally, you're going to rotate this. The top, the star will become like this. The entire figure will become like this if you rotate it, and the star is going to come here. So, see, it doesn't look the same. You see, so basically the orientation of the figure is not preserved in reflection and rotation. Am I making sense? Does it make sense? So, okay. So see here, I'll let you know an example. So you can clearly understand what I'm saying. Wait, let me get the figure for you. So here orientation is preserved. Here orientation is preserved. Here orientation is not preserved. Let me show you. I'm going to erase everything in here. Okay. Anirudh, are you following Anirudh?
Miss Priya,
Yeah.
I couldn't completely understand for the flip or the reflection on why if it were gonna go to the x-axis, it wouldn't be preserved.
That is, you're talking about reflections, huh?
Yes.
Yeah. So, no. See, you cannot separate it as, oh, if it is reflected on X or reflected on Y. There's no separation. Reflection, there are cases where it won't be preserved. So, coming to orientation of the figure, right? Okay. So, this is the orientation of the figure. If you have this figure and then transform it here the orientation is called, it's preserved. Okay. In this scenario, whatever you do, what you have done here basically you have rotated the figure, I would say, rotated and translated the figure. So basically orientation is not preserved. These are examples where it is preserved and not preserved. Okay. Coming to clarify this, in translation, it is preserved. Okay. In reflection, it's not preserved. And so in rotation too, it's not preserved. Make sense? Make sense?
Yeah, makes sense.
Can you give me a second to write this down?
What is it?
Can you give me a second so I can write this down?
Yeah, sure. Let me know once done. There are two things that I want you to learn. One is orientation of the figure. The other one is the orientation of the vertices. Can I move on?
Yes.
Okay. So you got this. Okay. How about there is one more transformation which I did not talk to you about. Okay. I know I'm shortening whatever transformation I want to discuss in detail with you for lack of time. I'm literally shortening and you have to know that. Okay. So the other transformation, nothing related to these three, is something else called dilation. Have you heard of the term dilation? What is dilation? Who can tell me? If you're wearing glasses, you should know what is dilation.
Dilation is essentially like, isn't it kind of like in eye case? All I know is that it's kind of like it essentially takes the pupil and like is completely enlarges it.
Ah, good job. That was the exact word I wanted. It enlarges it. It can, see, dilation can end up in enlarging or reducing.
So it's like resizing?
Yeah, resizing, yes. You're resizing. So when they dilate your pupil, when you go for the eye checkup, when they dilate the pupil, it means that they're enlarging it. So making it bigger so that they can see better. Okay. However, dilate, yeah, go ahead.
How about in time?
Huh?
For dilation, like I've heard of it for like time.
Oh yeah, time dilation, time dilation. Good, nice. Yes, Anirudh. That's true. So the dilation can be enlarging or reduction. Okay. Suppose I have this 2 units. Okay. I'm going to dilate it. I'm going to dilate it with a scale factor of 2. That means, will my image going to be enlarged or reduced? This is pre-image. Image is going to be enlarged or reduced?
Enlarged.
Enlarged, because my scale factor is 2. You see? Bigger than 1. If my scale factor is 1, what will happen to the size of the image?
It's gonna stay
It
the
stay
same.
the same.
Stay the same. They are going to be congruent figures, right? If the scale factor is 0.5, what happens?
It would get smaller.
That's
Reduced.
half.
All these two are dilations. You got it? One major difference. Why did I talk this first to you and then separated this out? That way you will remember forever. There is a big difference between this set and this set. What is it?
It doesn't preserve congruence.
Good, nice. What did he say? He says this preserves congruence. This preserves congruence. Dilation does not preserve congruence. What does it mean?
Is it because of the fact that what do you call translation? All it does is just change the position, but
Correct.
dilation literally like enlarges it. So you're essentially resizing the shape.
Correct. So the image that you get from the pre-image is never congruent to the original pre-image. You see, dilation means enlarging or reducing. So there is no way the resulting transformed image is not at all congruent. It is similar, meaning the shape, this is small, you either make it bigger, meaning big, same shape, but big size, or you can even make it smaller, same shape, but small size. So you end up with similar figures, not congruent figures. Whereas here, there is no change in the shape or the size or the shape or the size of the image and the pre-image. That is why this preserves congruence. This does not preserve congruence. Any questions here?
Nope.
Okay. I know I'm pushing a lot into you at the same time. But you know what? School will give you, meaning usually they give you the cheat sheet and you try to memorize it. I don't want you to memorize it. Okay. Reflection means you should understand. If it reflects on the x-axis, x value remains the same. Y coordinate becomes negative. It's easy to recollect if you understand how it works. Okay. Now, what did we study? Dilation. So basics we studied. Okay. Let's say a point 3, 4 is dilated by a factor of 2. What is the resulting point? What is the resulting point? It's dilated by factor of 2 means what? It is multiplied by factor of 2. So what happens? The resulting point is 6, 8.
8.
You got it? Yeah. Suppose same point is dilated by a factor of half.
1.5
Becomes 3 by 2,
and 2.
4 by 2, which is 1.5 comma 2. Why? What is going on in here? See here. Suppose I have a triangle like this. Let's say, I don't know. Okay, let's consider a line, ma. Okay, I don't want a triangle and all because it'll all take time. Let's consider a line. Okay. In dilation or reduction, there is always, like in reflection, you have a line of reflection, correct? Line of reflection is the x-axis, y-axis, or any x equal to y line or y. There's always a line of reflection which acts as the spine in the book. When you flip a book, right, the spine in the book is the line of reflection. In dilation, you always have a point of dilation. Point of dilation at your level is just the origin, always the origin. So dilation means what? You are going to draw a line from that point of dilation to your A. You're going to extend the point. Okay. Then you will draw B. Okay, you're going to extend the point. Now, if this distance, let's say, is 1, okay, if you're dilating by a factor of 2, then I will mark a point 2 distance, 2 units from the origin. Okay, that becomes A dash. Now B, let's say this is 2 units already. Okay, if I dilate it by 2 units, 2 times 2, 4. So somewhere here will be my B point. Do you get it? So B dash. Now join those, that will be A dash B dash. Got it? So dilation happens, you need to understand. Here this is the dilation means you're either enlarging or shortening, reducing it. Okay, the factor tells you how to reduce or enlarge. You have to multiply by that factor. Okay, so from A to find out A dash, you'll multiply by the dilation factor. From B to B dash, you'll multiply by the dilation factor, mark the points and connect the points A dash and B dash. So this is dilation or reduction. Okay, so this is all about this type of transformation, right? As Prince said, does not preserve congruence. Okay, whereas the other three are what? Translation, reflection, rotation. Remember, they preserve congruence, correct? The shape, the pre-image and the image are the same, so they preserve congruence. That is why, since they preserve congruence, since the shape of the object does not change, the size of the object does not change, those three are called rigid transformations. Any questions? Those three are called rigid transformations. Okay, I'm not thinking that you'll observe 100%, but at least 90%. If you can get the base, then it's very easy. Can I move on? Can I move on? Or do you have any questions now? Guys, it's your turn to answer, right?
I don't have any questions.
Okay. Let's say this one. Another concept. We discussed congruence preserving, orientation of the figure preserving. We are going to learn one more of that. What happens here? A, B, C. What are they doing here? They are rotating. They are, what are they doing?
Rotating.
They rotated the figure. Literally, they rotated the figure and then moved the figure. They rotated the figure. They rotated the figure by 270 degrees and then translated the figure to go here. Okay, rotation plus translation happened here. Okay, but this is your pre-image. Okay, this is your image. Okay, now start from any point. Okay, let's start from B. Yeah, let's start from B. Okay, B, C, A. Am I making sense, guys? Here in the image, let's start from the same point, B dash. Okay, what happens here? B dash, C dash, A dash. Do you see the order remains the same? Order of the vertices remains the same. Do you all agree with me? Do you all agree with me?
Yeah.
Yeah.
So This is called orientation of the vertices. Orientation of the vertices. So in translation, in rotation, what happens? It is preserved or not preserved? Are they both the same?
Oh, wait, will they not be preserved?
They are preserved, right? They're exactly the same, right? Then we BCA.
Well, oh yeah,
Hmm?
because I thought.
When you rotate and translate, whatever it is, right? The orientation of the vertices remains the same. How about reflection? This is reflected on the x-axis. So let me start from any point. Okay, see. See, you can either go clockwise or anti-clockwise, but you have to follow the same procedure in both. CBA. Prisha, are you following?
Yeah.
In my pre-image, in my image, I go anti-clockwise. C dash, A dash, B dash. You see, is it preserved? Is it preserved? Is the order of the vertices the same? CBA in the
No,
pre,
it's not the same. It's not.
it's not preserved. So you need to understand when it is preserved and not preserved. So basically, translation, rotation, and dilation. When you dilate it, it will be automatically preserved. Nothing is happening to the vertices. So order orientation of the vertices is not preserved only in reflection. Orientation of the figure is not preserved in reflection and rotation. But if an object is rotated at 360 degree, the orientation of the vertex, the orientation of the figure is preserved. Okay. Now coming to orientation of vertices, you just choose any vertex, go in a clockwise or an anti-clockwise direction in the image and the pre-image do the same thing. Start with the same vertex, go in the same direction. If the order of the vertices becomes the same, then it's preserved. The order of the vertices is not the same, it's not preserved. Any questions? Any questions for me? But that was a lot for you to digest, right, today? I think so, honestly. Yeah, see, while I want to go ahead a little bit, I really want you to digest this better. So this forms the base of your transformation. You get it? Meaning tomorrow, see, this is what I will do. I'll tell you what I'll do. This is very easy for me. This is the cheat sheet. Go ahead and study this. Just use this. Do the work. That's very easy. Okay, that anybody can do anytime. Hold on, I'll show you. Wait. I don't want you to do that. Okay. That you can do it when it comes to geometry when you don't have time. Now is the time you have time. Understand and study. Let me show you. Okay, yeah, this one. I have it in here. See, this is what I will do. But you know what? This is very easy work. See, there is a transformation cheat sheet. I'll share it with you. No problem at all. Okay. Do you see? When it is reflected on the x-axis, what happens? It's given x comma y. So tomorrow I'll ask you, hey, what happens to 3 comma 4 point when I reflect it on the x-axis? You can see this and write down, oh, x remains the same. Y becomes minus y. This is your answer. This is very easy. If I give you the sheet, right, you can just map. This is your original point, right? When you reflect it on the y-axis, this becomes minus 3 comma 4. X gets negated, y remains the same. You see? If you reflect it on the y equal to x line, right, they switch places. So 3 comma y becomes 4 comma 3. These are all very easy when you use the cheat sheet. But for you to understand is very hard. Okay. But today what we did, we just understood this. I didn't cover rotation at all. I covered translation and dilation. You get it? So next week when we meet, right, I'll give you inputs on rotation. Okay. One request I have for you. Okay. I know I did not cover rotation, but the homework that I'm going to give you is going to involve everything. Okay. You are going to leave all the questions that are about rotations. You're going to just do reflection, translation, and dilation. And then orientation of vertex, orientation of figure questions are going to be there. You can do that. Does that make sense? You can leave all questions related to rotation. But you know what? If you're really wanting to understand transformation, right? I'll also share the cheat sheet. If you use the cheat sheet, you'll do the homework very easily. Okay. But without it, I would really ask you to do translation, reflection, and dilations alone. Okay, rotations, don't use the cheat sheet for now. Let's understand it and then do next week. Make sense? Okay, usually I take 3 or 4 weeks for transformation. Okay, I just squeezed it into just short, but that's okay. You are again going to learn transformations in geometry, and this is a part of grade 8. That's why Star did not ask you questions on this. Make sense? Okay.
We did questions on this in Star.
Oh, you did grade 8 Star, right, Prince?
Yeah.
You did grade 8 Star, right?
Yes.
Yeah. There are some others who have done grade 8 Star in this class. Okay, Sanvi also did grade 8 Star. That, okay. Did you get questions on transformations, Prince?
Yes.
Okay, good to know. Okay, so good to know. See, Star, the the score that you get, it's not that important to move on and all. So it's fine, however you do. That's why they go ahead and give you, even if you're in 7th grade, they feel that it's okay to give you the 8th grade Star. Some schools, not every school. Got it? Any questions for me? Any questions for me? Guys, any questions for me?
No.
No? Okay. Can we stop here? Do you think we can stop here? Okay, I'll give you questions, but please omit rotations. If you want to, definitely try. I have no problem in you trying. Okay, I'll stop here, guys. See you all next week. Okay, otherwise ping me for the question ping.
Bye, Miss Priya.
Bye. Bye.
After next week, we don't have any class, right?
Oh yes, no, summer we have ma. I will circulate. Summer I'll have it, but
Yeah.
I don't force you to attend.
Thank you. Like, I mean,
Maybe-
for this semester, like.
Yes, semester we are ending.
Thank
Okay.
you.
Yeah, whichever group comes in and we get started, I'll move on with the algebra one.
Thank
Got
you.
it? Bye, ma. Any questions for
Miss
me, guys?
Priya,
Mm.
in school we had the CBE test for algebra, so people who wanted to CBE could CBE. I didn't CBE because I thought like algebra was like really important for math. It's like basics of math. So I thought not skipping it would be better.
Don't skip. Okay, let anybody
So
do. You
instead
don't
of skipping algebra, should I do
skip
CBE
geometry.
for geometry?
I would love for you to do.
Yeah.
You
I
are a very good candidate for that.
okay.
You
Yeah.
should do.
Also on math map, I got Pythagorean theorem questions and transformation questions.
You did that?
Yes.
Oh, that's good.
And I was so happy. No, transformations I didn't learn, but like
I know. Sorry.
I don't know, I just knew. No, I got the questions right though,
All
because I
right.
still got calculated questions.
Yeah.
I just got it.
See, some logic is important as well from the brain.
Yeah, but I only got like 3 or 4 questions for transformations.
It's good.
Yeah.
Pythagorean theorem you did?
Yeah.
Nice. Very good
Yeah.
job.
I was so happy because like I just learned it and I
And
got
it
the questions, so it was like really fresh.
That's nice. But you should do geometry. I don't know about your summer plans. Okay. But you talk to your mom.
Mhm.
No hurry. But I feel like I can divert you a little bit into geometry. Let me talk to my mom, to your mom sometime.
Okay, yeah.
Okay. Ask her to ping me sometime next week.
Okay,
Okay.
yeah.
We have to talk about your path or whatever. I would like you to take geometry CB.
That's what I was thinking. I was thinking of doing geometry CB, then algebra CB.
We'll see that later. First do geometry CB. But for that, should you, I will talk to your mom.
Okay.
That's it.
Yeah. Do you know when they're when
CBE is in March, Ma. Meaning, honestly, if you want to CBE, I will. There is a group that's coming for geometry. Okay, that group I will finish. I'm planning to finish by February for the CBE.
oh next year? Oh, when is it starting?
We'll start in June, right?
Oh, okay. You can
But
talk to my
but there
mom.
is no force, there is no
Yeah.
pressure. But I want to talk to your mom and let her know, left to her and you to decide. Got it?
Yeah. Okay.
Okay. Bye bye.
Hi, Miss Priya.
Bye. What's up, Avyukt?
Nothing. I just want to listen to our questions.
Oh, sure.
Yeah.
Good.
Yeah.
Nice.
All right. See you. Bye.
Sure. Bye. Bye, Avyukt. Nice to have you in class. Nice to work with you.
Teacher.
Bye.
Bye.